Hello everyone, welcome to this video lesson. We are in wave optics. As it is being said in the previous video lesson that properties of the physical optics like interference, diffraction are explained based on Huygens wave theory. First, I would like to explain some basics of this wave equations itself so that further understanding becomes easy in the coming lessons. So, first of all, what do you mean by a wave? If you are to understand what do you mean by a wave? Wave is a periodic disturbance through which transfer of energy and momentum happens. So, for this to happen, according to Huygens at least being a mechanical wave where either medium is proposed, there shall be a medium. That medium shall be having properties like elastic in nature so that it can transfer energy to the next particles. Now, each particle of the medium vibrates about its mean position, oscillates. It temporarily oscillates, moves away from its mean position, transfers the energy to the next particles, and comes back to its original position. And how much the particle got displaced from the mean position can be determined by using a equation y equal to a sine omega t plus or minus phi, where y is the displacement of the particle from the mean position after time t. A is the maximum possible displacement that the particle can have, called amplitude. This omega t plus or minus phi is actually together called phase. That's the position of the particle with reference to the main position. This phi is called initial phase. Initially, if the particle starts about the main position, then the phi value becomes 0 itself. Right? Now, understanding this equations even a little further, if all these are being learned in first year, I'm just briefing the basics only. If wave is advancing along positive axis, the representation is something like y equal to a sine omega t minus phi. If it is moving towards negative x-axis, then we can write a formula y equal to a sine omega t plus phi, where this phi is called something like initial phase or epoch. So it is clear that as we move with respect to the time, the position will change. So we want to find out how does the position will change with respect to the time, or that is with respect to the phase. So there are different kinds of the waves. If you consider a simple, say, transverse wave, this is called a crust, this is also called a crust. The distance between the two identical points is called a wavelength, lambda. Both of them are in the same phase. So we can say in wave motion, when two particles are separated by wavelength lambda, being there in the same phase, the phase difference between them is 2 pi. If separation is 1 unit, then the phase difference between them is 2 pi by lambda. If the separation is 2 units, then the phase difference between them is 2 pi by lambda into 2. If separation between the two particles is delta x, which is also called as path difference, then the phase difference between them will be 2 pi by lambda into delta x. This is the relation between phase difference and path difference. So if somebody say the two particles are separated by something like lambda by 6, then the phase difference between them will be 2 pi by lambda and lambda by 6. That's nothing but 2 pi by 6 or pi by 3. That's equal to 60 degree. That's how we can find a relation between phase and the path. Anyway, this 2 pi by lambda is a constant, and that constant is called phase constant, shown with the letter K. It is called something like phase constant. So delta phi could be written like phase constant K into delta x, or I can write simply phi equal to Kx. So rewrite these equations as y equal to a sine omega t plus or minus kx. We can rewrite that equation as omega t plus or minus kx. So when you are talking about a wave, this wave will have a velocity. We can say wave velocity is something like n lambda. Even the particle of the medium, while it is oscillating, will have a velocity who is different from this wave velocity, that is omega into root of a square minus y square, right? So you can use all these basic equations while we are solving the wave optics and its concepts further, right? Thank you for watching. Keep coming back for more and more video lessons. Thank you.